Good morning, scholars. Happy Wednesday. Happy April Fool's Day. Today is Wednesday, April 1st. I'm excited for us to dive into our third lesson in Unit 7 on multiplying decimals today. I do want to start with some shout outs for some 100% on yesterday's assignment. So huge shout outs to the 100% club in UNC. This was Emmanuel, Lyric, and Dillery. Extra shout out to Emmanuel, who took the time. He had one question. He came to office hours, got his question correct, and therefore scored a 100%. Nice work. In SCU, we had Danya, Nevaeh, and Adam all scoring 100%. And Duke, you guys need to step it up. You only had one scholar scoring a 100%. So huge shout out to Camila. Would love to see some more representation from Duke tomorrow. Would also love to see some more representation from the other classes as well. So bring it on. All right, a quick reminder before we begin that every day you should be logging in to your Google Classroom, checking out your VCP 5th grade math. You should be doing this in the morning so you can see if you were invited for reteach. If you were invited for reteach, make sure you're clicking on this link, and please be prepared with paper and pencil. If you have a marker, that's really helpful to help us see your work. If not, a pencil is fine, but make sure you're logging in by 10:45 for that reteach. One final announcement is now that we have started getting our work submitted, you'll start to see your grades. Every morning when you log in to see if you've been invited to reteach, this is a great chance for you to also check your grade from the previous day. There's two different things that go into your grade. One is the accuracy. This is the score that pops up after you finish your quiz, and it might say, oh, you got 3 out of 4 or 4 out of 4. And then the other part is around the completion. Did you complete the entire assignment? In order to get credit for completion, you must watch the video. You cannot just click on the independent practice and try to submit that. There's a lot of math that you're doing in the video as well. I know I talked to a couple scholars yesterday who said that they hadn't been watching the videos. Make sure that starting today, you are always watching the video. Starting today, I'm going to be telling you just a little story about my new puppy, Watson. We'll pause throughout the lesson, and I'm going to tell you just some fun facts about Watson. You can even write them down if you want, because one of them will show up on your independent practice. That should be the easiest question you get right. So when you're ready to check out your grade, you'll click where it says classwork. You'll scroll down to the daily lesson. If you want to see your grade from yesterday's assignment, March 31st, you would just click on it, decimals to fraction, and scroll down to where it says view assignment. Within the assignment, you'll get some information about your own grade. So your grade will pop up and you'll have some feedback. Today, everybody who submitted their assignment got some feedback from me. Once you get your feedback, you're just going to respond to the feedback in the chat by just saying, got it, or if you have a further question, you can ask that as well. Please make sure you're checking your messages. This is how we're going to be communicating with you during this time. All right, so today, when you're done watching this video, this would be a great time for you to check your grade from yesterday. You may notice that even if you did okay on the independent practice, if you did not watch the video, overall your grade's not going to be as high. Today, I know everybody's watching the video and we'll all do so well on our independent practice. All right, we are ready to begin. Make sure you have your blank paper, you have a pencil or something to write with. We are going to jump right in to multiplying some decimals. We spent the last 2 days working on multiplying one decimal by a whole number. This allowed us to use strategies like repeated addition. I could add the decimal over and over again the number of times that the whole number told me to multiply by. Today, we're going to notice, because we're multiplying a decimal by a decimal, we're not going to be able to use that repeated addition. Looking at today's problem, we're just finding the product of 54 and 6/10 and 13 and 4/10. I can't add 54 and 6/10, 13 and 4/10 times. So I'm not going to be able to use repeated addition. Luckily, we have several other strategies that we know how to use. So I am going to start you off with some work time this morning. You are solving 54 and 6/10 times 13 and 4/10. Don't forget to start with an estimate. You could use the standard algorithm. You could convert your decimals to fractions. You can use partial products, whatever strategy you would like. I'm going to set our timer today. We'll start off with 3 minutes on the clock, and then we'll check in and see what you have. Don't forget to estimate, and if you finish solving it in one way, you can always solve it in a second way. All right, happy work time. Go ahead and get to work. We're in our final minute. Final 10 seconds. All right. Go ahead and put your pencils down. I should be right up here. Let's check in and see what you got. So I started off by writing down my problem. 54 and 6/10 multiplied by 13 and 4/10. I knew the first thing I needed to do was figure out about how much this is going to be. I needed to estimate. So I rounded both of my numbers to the nearest whole number. I knew that 54 and 6/10 would round up to 55, while 13 and 4/10 would actually round down to 13. In order to solve 55 times 13, I used my standard algorithm. For me, that's the fastest way. And I got to an answer of 715. So I know that when I get my answer, it should be around 715. It shouldn't be 71. That would be too small. It shouldn't be 7,150. That would be too big. It needs to be around 715. All right, let's take a look at a couple of the different ways I saw some scholars solve it. Some of us are starting to feel more and more confident with the standard algorithm. So let's take a look at how we use the standard algorithm to solve it. If you did not solve it using the standard algorithm, I want you to find some space on your paper to solve it with us. If you already solved it using the standard algorithm, you're just following along and making sure what you have matches what I have. So I'm going to set up my problem. 54 6/10 times 13 4/10. I'm going to temporarily remove both of these decimal points. And so for now, I'm going to be multiplying 546 times 134. I know that when I'm done multiplying, I'll have to check my estimate, see where that decimal point goes, and add it back in. But for right now, I can multiply it without the decimal. All right, follow along as we do the standard algorithm. Go ahead and do your first row. Double checking that you got 2,184. As I move over, I know I need to add my 0 since I'm really multiplying by 30. And double check that you also got 16,380. All right, now this is a big one. I'm not done. I need to multiply by this 100. And since I'm multiplying 546 by 100, I'm not just putting 1 0 as my placeholder. I actually need to put 2. Now I'm ready to multiply. Luckily, I only have to multiply by 1. 1 times 6. And keeping my digits nice and lined up, I'm going to go ahead and add all of my products. And I got to a final answer of 73,164. I want to go back to my estimate for a second. When we estimated by rounding our decimals to the nearest whole numbers, we knew we were looking for an answer around 715. 73,164 is way too big. So I need to figure out where my decimal point goes. I need something around 715. So I'm thinking, okay, 73,000 is too big, but 731 is pretty close to 715. I also noticed that I had 2 digits after the decimal point in my original problem, so I can move my decimal 1, 2 places. And when I get to an answer of 731 64 hundredths and compare that to 715, that's really close. And so I know I'm on the right track. If you multiplied and you used the standard algorithm and you got to the same answer of 731 64 hundredths, nice work. This was a really big problem. Go ahead and we're going to draw ourselves, today we're going to draw ourselves a lovely balloon. to celebrate your excellent, excellent work. Nice job. Let's take a look at one other way I saw some scholars solving this problem. There were some scholars who I know yesterday were really enjoying converting our decimals to fractions. And so let's try that with this problem right here. If you did not already solve it by converting your decimals to fractions, please find some blank space on your paper so you can follow along and do it with us right now. First thing I'm going to do is rewrite my problem, turning my decimals into those fractions. I'm pretty good at this because when I say the number with the decimal, it basically gives me the fraction. 54 6/10 times 13 4/10. All right, I'm going to go ahead and set up an array to multiply all the different pieces. I know when I'm multiplying, I can't just do 54 times 13 and 6/10 times 4/10. Instead, I need to multiply every piece times another piece. So I need to be multiplying my 50 times 10, my 50 times 3, my 50 times 4/10. I need to multiply my 4 times 10, my 4 times 3, my 4 times 4/10. And I need to multiply my 6/10 by 10, 6/10 by 3, and 6/10 by 4/10. So I'm going to set up an array. This way I can keep track of everything that I'm multiplying. Nice and neatly. All right. In my array, let's start with our 54 6/10. We have 54 6/10. And now let's put our 13 4/10. I know that's 10, 3, and 4/10. All right, now I'm ready to multiply. Let's just start right up here. These are some of my easier numbers. 10 times 50. I know 1 times 5 is 5. Add my 2 zeros. 500. 10 times 4. Really easy breezy. 40. 10 times 6/10. I know when I'm multiplying those fractions, I multiply my numerator. I know that, and then my denominator. I know my denominator for 10 is just 1, so I'm doing 10 times 6 is 60 tenths. And that's an easy one for me to reduce. I know that 60 tenths is the same as 6. All right, let's keep going. 3 times 50 is 150. 3 times 4, 12. And 3 times 6/10 is 18 tenths. And I can reduce that to 1 8/10. All right, one more row to go. Now I have a fraction. 4/10 times 50. I know I need to multiply my numerators, so 4 times 50 is 200 over my denominator of 10, 200 tenths, which we can reduce to 20. 4/10 times 4. 4 times 4 is 16 tenths. And we can reduce that to 1 6/10. All right, my fraction times a fraction. 4/10 times 6/10. This is where I really don't want to get tricked. I need to make sure I'm multiplying both my numerators and my denominators. This is the first time I'm multiplying something that actually has two denominators, excuse me, where one of them isn't 1. So 4 times 6 is 24. 10 times 10 is 100. So I have 24 100ths. Wow, there's a lot going on in this box. I want to make sure I know what I need to add. I'm going to just cross off my fractions that weren't reduced. I want to make sure I'm not double adding anything. So now I can see the quantities I need to add are 50 plus 40 plus 6 plus 150 plus 12 plus 1 and 8 tenths plus 20 plus 1 and 6 tenths plus 24 100ths. Let's start with just our whole numbers. I think that's going to be a little bit easier. I'm going to do a little bit of mental math and then write down the parts that are a little bit more tricky. When I look across this row right here, 500 plus 40 plus 6, I can quickly add that in my head. That equals 546. I'm going to give myself a check by each number that I already added so I don't lose track. I also know that 150 plus 12, that 150 plus 12 is 162. That's just pretty easy mental math for me to do. And then I still have a 20. So I'm going to add up my 546 plus 162 plus 20. I'm just going to set up my typical standard algorithm for addition. And go ahead and solve this. All right, again, I have checks in all the boxes I've already added. I chose to just add up my whole numbers first because that was easiest for me. So I've added all of my whole numbers. I now need to add in my fractions. I have 1 and 8 tenths, 1 and 6 tenths, and 24 100ths. Let's start with the two fractions that have the same denominator. So I'm going to add 1 and 6 tenths plus 1 and 8 tenths. I'm going to add my whole numbers first. 1 plus 1 is 2. 6 tenths plus 8 tenths is 14 tenths. But I know that 14 tenths is the same as 1 and 4 tenths, plus I already had 2, so this will give me a total of 3 and 4 tenths. I've now added my 1 and 6 tenths and my 1 and 8 tenths. All right, the last thing I need to add is my 24 hundredths. Just move this over so everyone can see. All right. This is how much I got when I added my whole numbers. And this is how much I got when I added up my 1 and 6 tenths and 1 and 8 tenths. Let's go ahead and add those together. I know 728 plus 3 and 4 tenths is going to be 731 and 4 tenths. So I just need to add in this final piece of 24 hundredths. Okay, before I can add, I know I need to have a common denominator. I need to turn my 4 tenths into hundredths so I can add. By multiplying each by 10, I can get 40 hundredths. When I add 40 hundredths and 24 hundredths, I get 64 hundredths, which means I get a final answer of 731 and 64 hundredths. Whew. Let's go back and check to see, does that match what we got when we use the standard algorithm? 731 and 64 hundredths. 731 and 64 hundredths. It matches, and it is really close to my estimate. Nice work. I want you to think for a second, which of these strategies works better for you? The standard algorithm was a little bit more efficient, but if you have a hard time really thinking about where to put that decimal and you would like to continue turning your numbers into fractions, like we did, you can continue using that strategy as well. Let's take a look at a couple more problems together. All right, I am out of room on my scrap paper. I definitely need to find some more. I'm going to flip my paper over. So we can take a look at problem number 1. All right, let's try problem number 1 using our standard algorithm. See how comfortable we're feeling with this, because it is a little bit more efficient. Make sure you set it up on your scrap paper. First thing I need to do is write down my estimate. I'm going to estimate this by rounding 25 and 6/10 to the nearest whole number. Go ahead and write down what that nearest whole number is. And then I'm going to round 12 and 4/10 to the nearest whole number as well. On your own, go ahead and complete your estimate. What is 26 times 12? You can use a standard algorithm. You can use partial products. Go ahead and solve this so we know about the answer we're looking for. Okay, I got you an answer of 312. If you also got an estimate of 312, nice work. Give me a big thumbs up. Excellent. All right, now that I know I'm looking for an answer of around 312, not 31, not 3, not 3,112, we're ready to multiply. I'm going to temporarily remove my decimal points and rewrite my problem as 256 times 124. All right, go ahead and solve. I want you to try this on your own. Don't forget, when we get to the 100, don't forget we need to add those 2 0 placeholders for the 2 zeros in 100. Go ahead and multiply on your own, and then we'll come back and check it. Ten more seconds. All right, let's check in. I got to an answer of 31,744. If you also got to 31,744, nice work. You multiplied correctly. Quick air high five. Get ready. Nice job. But wait a second. I compare this to my estimate of 312, and I remember I took out those decimal points, and this number is just too big. I can't really have 31,744. I need to put my decimal point back in. I just took it out temporarily. So I need something close to 312 that has 1, 2 digits after the decimal point. See if you can figure out where the decimal point goes. Take 10 seconds. All right. I know it can't go here. 3,100 is still too big. When we took it out and had 2 decimal places right here, I'm going to move it back in 2 places. If you put your decimal between the 7 and the 4 and you got to an answer of 317 and 4400ths, you crushed it. Nice work. Go ahead and give yourself a nice smiley face. I'm going to have mine sticking out their tongue today. All right. Excellent work. We're now going to try solving it using our fractions. If you decide after this that you love the standard algorithm and you don't want to have to solve it using fractions, you don't have to. I want us to try it one more time to make sure you know what to do, and then you can pick the strategy you like the best. Solving it with fractions also helps double check that our multiplication when we took out that decimal point still works. So let's rewrite it using fractions instead of 25 and 6/10 as a decimal. Go ahead and write it as a fraction. And instead of 12 and 4/10 as a decimal, go ahead and write it as a fraction. I'm going to set up my array, make it nice and big to give myself plenty of space. All right, on your own, go ahead and set up the numbers that go on either side. Try it first, then check up here to see if yours matches mine. All right, I want you to try solving this one on your own. Let's take 3 minutes and we'll check in and see how far we got. Remember that we're going to figure out the product in each box. Don't get tricked when we start multiplying fractions by fractions. Then we'll start adding up all of our products. I like to put a check in the boxes I've already added so I don't lose track. 3 minutes. Go ahead and get to work. If you've finished your array and you want to just check in to see if what you got matches mine, I had some fractions where I then reduced them, and so I'm just going to cross out the numbers I'm not going to use. So I can see everything I still need to add. If you're still multiplying, that's totally fine. This was just if scholars were done and wanted to check in. I'm now going to begin adding up all of my products. I always like to give myself a check in the boxes where I've added. That's the end of our 3 minutes. Take 20 more seconds and finish it up. All right, let's see what you got. Once we multiplied all of our products and added them up, you should have gotten to an answer of 317 and 44 hundredths. I'm going to check back, and it matches what I got when I used the standard algorithm. It is your choice which strategy you would like to use. If you like using fractions, feel free to use your fractions. If you prefer the standard algorithm, please feel free to use the standard algorithm. I am not going to make you use one strategy or the other. I just want you to see how both of them work. And now we have those two strategies. I know what I can't use right now is repeated addition because I can't really add 25 and 6/10, 12 and 4/10 times. All right. We're going to solve one more together, but before we do that, I do want to tell you a little bit about my new puppy, Watson. So this is Watson. He's pretty cute. I just got him. And he's a little fluff ball. And Watson has white fur. And here's a hint. You might want to write that down if you're worried you might not remember it. Watson has white fur. So if someone asks you, what color is Watson's fur? You would say, oh, it's white. Watson has white fur. One more hint, you might want to write that down if you think you might forget. Or you can remember it because he kind of looks like a little fluffy snowball, and snowballs are white. So Watson has white fur. Remember that. It's going to be really helpful later on. All right, one more to try together. On this one, you may choose standard algorithm if you love standard algorithm, or fractions. I won't make you solve it both ways. We will take 3 minutes of work time to solve. If Richard bought 32 and 4/10 pounds of soil for his garden, and each pound cost him $2.86, I need to know how much money did he spend. 3 minutes to solve, and then we'll check in. You don't need to solve it two ways. Just pick one way you'd like to solve. Go ahead and get to work. Don't forget to solve your estimate first. Let's just check in really quick about our estimate. When I went to estimate this product, I rounded my 32 and 4/10 to 32, and I rounded 2 and 86 hundredths to 3. When I multiplied those, I knew I was looking for an answer of about 96. Now, when I set up my standard algorithm, I knew I was able to temporarily take out those decimal points. And so I can think of it like multiplying 324 times 286. Just wanted to make sure everyone had that lined up correctly. Go ahead and get back to work. And if you were using fractions, that's great. You can do that as well. Just a quick check-in for any of my friends using fractions. If you set up your area model, this one looks just a little bit different because I only have 2. I don't have anything in the tens place right here. So this is what it could look like if you set up your area model. One final minute of work time to finish it up. All right, let's check in and see what we got. Let's start with our standard algorithm. Double check if you use a standard algorithm that your digits match mine. That we got 1,944, 25,920, and 64,800 for a sum of 92,664. I compare this with my estimate of 96. Whew, this answer is a little too big. I need to figure out where my decimal point goes. I know I need an answer of around 96. I also see that I had 1, 2, 3 digits after the decimal point. So I'm going to move my decimal 1, 2, 3 places for an answer of 92 and 664 thousandths. If you got that and you got the decimal in the right place, really incredible work. Give yourself a huge check. Nice job. For anyone out there who solved it using fractions, it does take a little bit more time. This had quite a bit of fraction converting to do, but when I was done, I did get to an answer of 92 and 664 thousandths. Same answer. Whichever strategy you prefer is up to you. All right, your turn to try a couple on your own. All right, find some new scrap paper if you need to. You can go ahead and solve question 1. It is your choice what strategy you want to use. Also totally fine because this is multiple choice, if you see a way that you can eliminate certain choices based on your estimate, that is fantastic. So don't forget to estimate first. You may not even need to solve the whole thing in order to answer this multiple choice question. And when you are done, we'll scroll down to the next one. Again, you can pick whichever strategy you want to use. We'll take 6 minutes, 3 problems for each. Go ahead and get to work. Did anyone already figure this out just based on your estimate without having to actually solve it? Pretty cool. If you already did that and you already have your answer choice circled because you used a really great estimate, you can go ahead on to problem 2. Number 2, I can't quite figure it out just based on my estimate, so I'm going to have to pick a strategy I want to use to solve. All right, final 30 seconds. All right, let's check in. Question number 1. I saw a lot of scholars using some really smart estimating moves. After rounding 18 and 42 hundredths to the nearest whole number, or 18, they rounded 3 and 54 hundredths to the nearest whole number, or 4. When they multiplied 18 times 4, they got 72. As we look through our choices, I realized 652 is way too big. 6,520 is way too big. And 65,206 is way, way, way too big. I didn't even need to solve this. I know that since I see 1, 2, 3, 4 digits after my decimal point, I need 1, 2, 3, 4 digits after my decimal point. So if you had A, you are correct, and you didn't even have to do any math. Nice work. So if you got A, especially if you got A without having to do all of that multiplying, go ahead and give yourself a star. Nice work. Let's take a look at number 2. Now, number 2, I want to estimate again. I'm at around $2.68 up to $3, and 14 and 5/10 gallons up to 15 gallons. When I multiply 3 times 15, I get 45. Now, I look at my choices, and 45 is a choice, but I know my answer isn't going to be exactly 45 because I rounded both of these numbers up. And so these are all pretty close. I see one that might be a little bit too small, but I'm actually going to have to solve. So here, I chose to use the standard algorithm. This is what it looked like when I solved using the standard algorithm. I took out my decimal point. I lined up my numbers, 268 times 145. I got to a total of 38,860. I knew I needed to move it 1, 2, 3 decimal points to get me to an answer close to 45. And that's how I got 38 and 860 thousandths. Because it's money, we just write it as $38.86. And as I go back to my answer choices, that matches B. If you also got B, go ahead and give yourself a choice, a check, a star. Give yourself a star. I was able to estimate in this problem because the answers were so drastically different. 65, 652, 6,520, 65,000. These were all so drastically different, I could use my estimate to come up with the answer. These answers were too close. I couldn't tell if it was going to be $38.86 or $40.50. I had to actually multiply. All right, nice work today. You guys know the drill. You are going to be clicking on your independent practice assignment. It's kind of short today. Do make sure you're double checking. You'll get your grades back tomorrow. If you haven't seen your grade from yesterday's assignment, make sure you check that as well. And don't forget that Watson has white fur. If you didn't already write that down, you might want to write that down now. One final reminder, when you're done with your independent practice, please make sure you click the button that says Mark as Done. That's how I'll know you're ready for a grade. Tomorrow morning, make sure you're logging in to your Google Classroom so you can see if you've been invited to reteach, and you can check out your grade as well. If you would like to attend office hours, they're at 3:15 today. Click on the link in the assignment. Remember that you go to classwork. As you read the directions, there's a link to how you get to office hours at 3:15 if you need any help. All right, scholars, happy solving. Can't wait to see a few more 100% tomorrow.